All right, we got your slides up, Chance.
Beautiful.
Sorry about that. Thanks everybody for your patience. Yeah, Chance, get started whenever you're ready, man.
Yeah, if you want to go into present mode, I'll just ping you for a transition when it's time. Right on. Cool. Well, thanks everyone for waiting up and being patient here. So we'll just get started. So yeah, and thank you everyone thank you to Demetrius and Ryan and everyone at Reactadelphia for inviting me and having me here today. As you all know now, my name is Chance Strickland. I am a software engineer at React Training. I work primarily on the Reach UI component library, and recently we have started using finite state machines to help us better control and deal with state transitions in our components. So today I'm going to give a brief overview of what finite state machines are, why we find them useful, and how they can work in the context of React. And just as a quick upfront thing, this is a pretty heavy topic in all to really understand finite state machines and the whole concept in depth. It's going to take longer than a 20-minute talk. So we're just going to really scrape the surface and try to demystify how they sort of work behind the scenes pretty quickly. We're not going to cover everything, but I do want to give a brief overview, discuss some terminology, and then walk through some of the code for a state machine to sort of demystify how everything works behind the scenes and give you a better understanding of what's going on. So yeah, we'll go to the next slide. And so what is a finite state machine? It's a data model that describes how a system can behave within a finite given number of possible states. And there are 5 criteria that make up a finite state machine. It's a system that has a finite number of states, as I've mentioned. It has a finite number of events that you can send to the machine in order to queue off different transitions. It has a single initial state. It has a transition function that determines what the next state is given the current state and the event that is passed to it. And it has a possibly empty set of final states. Those are sort of a broad overview of the 5 criteria. And if we go to the next slide here, we'll ask the question, why finite state machines? So if you've been to a React or JavaScript conference in the last, I don't know, 2-3 years, you've probably seen this guy. This is David Korshid. And David works a lot with us at React Training. He's one of our contract instructors, and you can go ahead and navigate off of his face. But he's been out there spreading the good news about finite state machines and state charts for quite some time now. And he's made quite the dent. A lot of people are talking about them. I'm talking about them now. We only recently started using them at React Training in a lot of our software. And the reasons are many, but just very briefly, we all know that state can be very difficult to manage. There are no shortage of state management libraries out there, especially with React. But we know as systems become more complex, modeling and managing state can become hairier, and your app can become more error prone as a result. Now, state machines are a very old concept, and they've been used in large complex systems for many, many decades. They're just sort of making their way into the front end world, it seems, these days, but they've really been around for a long time. And the huge benefit that I think they provide is they just make complex state systems or any sort of complex system a lot more easy to reason about, and it makes it more difficult for unintended side effects to cause chaos to your system. And we use state machines in Reach UI so that we can make our components more predictable and make it easier to capture more nuanced interactions. And we'll bump up to the next slide. State charts. You'll hear a lot of people use these terms interchangeably, but essentially a state chart is the definition of a state machine. It can be a visual representation of it, or it can be an object representation, which I'll show you in code here in just a little bit. But the visual representation will look a little like this next slide. So in this particular example, we have a form that a person can fill out. The state chart is it represents the initial state of that form as empty form. That's the first state that you enter when you access this particular piece of UI. And based on these different arrows pointing to different events, with the little words above the arrows are signifying actions. And based on a different action you can take within a given state will dictate what the next state is. And that's sort of the gist of what a visual state chart looks like. So we can move up to the next slide and talk a little bit about terminology. So before we talk about terminology, I just want to point out, this is the part that I probably struggled with the most when I started working with state charts a lot. And the biggest reason for that is that there's a lot of overlap with terms that we're already probably pretty familiar with as React developers. And it's sort of important to distinguish them when thinking in this paradigm of state machines, because you'll hear the same words like events and actions and state, but they really do mean a little bit different concepts when we think about them in terms of a state machine than, let's say, the flux pattern or just general DOM events or anything. So like events, actions, states, all these things, we'll talk a little bit about what those mean if we go to the next slide. The first term is state. So a state is an abstract representation of a system, such as an overall application or a piece of UI at a specific point in time. And it's represented in one of the finite numbers of states that we provide, we talked about at the beginning when we were talking about what a finite state machine really is. And typically in finite state machines, this is represented in a string. So let's say your form can have a state of not yet submit, or I'm sorry, it could be an empty form, it could be idle, it could be submitting, it could be not submitted, but basically you have a singular state that your form exists in any given state of time. So it's sort of a fixed state of your form, but it doesn't necessarily encapsulate all of the data around that. An event is what causes a state machine to transition from its current state to its next state. An action is a side effect that can be triggered by a transition. Context, we'll talk about context. It really means contextual data. It's not context in the React context, create context meaning, but it's any sort of contextual data related to your state. A state transition defines what the next state is given the current state and the event that is passed. State transitions are defined on state nodes in the on property, as we'll show here in the code in here in just a minute. And a service is an interpreted running instance of a state machine. We're going to use a service to make state machines work with React, as you'll see in a minute. And if you're familiar with Redux, you can think of a service sort of like middleware for our state machine. So we will go to some demos now. And we can take a break from the sharing. I'm going to have to share my screen to walk through some of the code. I think it should be fine since I'm not sharing the presentation. So
yeah, I just stopped sharing. So you should be good to make the move.
Can you see my code?
Oh, dude.
You're kidding me.
Desktop.
You're kidding me.
Zoom hates you, man.
No kidding.
I think Zoom hates me, and you're just like a byproduct of the hatred for me.
What is going on?
Hey, Chance, do you have any of this in a repo?
So when you press share at the bottom, it doesn't give you like a full basic and advanced tag at the top.
I mean, it does, but none of them have my like what I'm actually looking at on my screen, which is
you know
bizarre.
What? Go into your security and privacy settings. Let me do it on my side too, so I can actually walk you through it.
You know, I have another idea too. I've got Zoom on my other laptop, and it's worked without this kind of
because I think what might be happening is that I just had to do it to share on my side too. Is that you might not have Zoom in your security and privacy settings, allowing Zoom to take control and share like specific windows and screens.
Yeah, that could very well be it. Give me 1 second. Let's see if I can pull it up.
There you go, man.
Dom, if not, we can try potentially looking at a repo if Chance has it on GitHub.
I will do whatever I can to assist Chance. I can even start dancing if he likes.
All right, so I just joined a different call with my other computer. So let me know if that works.
We got the chance. We got double chance.
Sweet.
We're just gonna fill this call with a bunch of Chance Stricklands. How many devices you got?
Enough, just enough. Enough to troubleshoot these sort of things.
Perfect.
Can you see my code yet?
Look at that. Yes, I can.
Oh, amazing.
Could you bump the text up just a little bit?
Awesome. Yes, I'm going to bump the text up. I'm going to change my color theme. Let's see.
So you're not going to need me anymore, right?
Yeah, I don't think so.
All right, cool.
There we go. I think that'll be a good theme to use here. Let's just get rid of this guy. Nope. This Zoom thing doesn't want to go away. Awesome.
Oh, is it the top corner where the videos are?
I think I'm good. Can you see everything?
Yep, we can see everything.
All right, right on. Cool. So I'm just going to do, and one thing to remember here as I'm talking is that this code it's overly simplified for a function, and it is really just meant to illustrate the concepts. It's not really it's probably not the best way to implement a state machine. It's not optimized in any way. It really is just illustrating those concepts. So I don't want to think too much about the actual code itself as much as what the code is trying to do. So without that blocking us, we will go through and get started. Now that I'm on. All right, we're on start. So I'll first, before I start showing any of the actual state machine code, I will talk about, I'll show what we're used to seeing in React, right? We've got, let's say we've got this widget, we've got a sign up for our newsletter form, and we can put in our email and see what happens. Okay, cool. We're signing up for this newsletter. Great. Thank you. Awesome. Looks great, right? Well, maybe. See what happens if we, okay, so here's an issue. We've submitted and we've got an issue here because we've got a thank you for signing up message, but we also have a please try your submission again later message. And as a user, this is very, very confusing because I mean, thank you for signing up. It appears as if I've signed up for this newsletter and nothing's wrong, but here it's telling me to sign up again later. Well, let's see what's going on here. So if we look at our app code, this is probably going to be a fairly familiar model for what a lot of folks are used to seeing in a lot of apps. You've got a lot of state, you've got some data that you're trying to set, you've got an error message that you might be setting to deal with an error, and you've got this loading state, right? You've got sort of these three different states that all sort of dictate what your app is doing at a given state and time. And we've got a submit function that we are firing when our form is filled out, and we set loading to true as we submit and we start the process. So we go off and we fetch some data. Got like this is just a randomized error so that I can actually see what happens when error takes place. But once we get some data back, we are setting loading to false. We are updating the data. We are, and if we have an error, we are going to set loading to false and set our error message, right? So far, so good. Now, if you go down into our UI code, you've got a bunch of conditional messages basically being sent based on these different pieces of state. So if we have some data, we're going to say thank you for signing up. We assume that we've gotten some data back, so everything's good, right? Awesome. But if we have an error, we're going to say something went wrong, try again later, whatever. And if all else fails, we'll just say sign up for newsletter because we'll assume that the newsletter form has not been completed yet. Same thing here. We've got some other components that are taking data, an error message, and a loading state, and just sort of doing with it whatever they're going to do. And this is something that you see a lot when you get you get a whole team working on some stuff, and everyone's sort of working on components in silos. And maybe you have one person working on this message text component, another person is working on the form component, and the higher level component, you're sort of just dealing with all of this state, right? And everything else is just supposed to do with it, whatever it's going to do based on these different pieces of state. Well, we see this bug and we think, what's going on here? Well, first of all, this is going to be a little hairy to debug because we've got three different pieces of state that we're trying to deal with. We've got, this data thing, we've got this error thing, we've got this loading thing. All of them are sort of doing the job that the form itself should be doing with just one piece of truth, right? And there are a number of ways that we can solve this. We don't need to come up with a whole state machine code to deal with this potential issue, but I'm going to talk about why the state machine could make this a little bit easier. So let's see what this code looks like with a state machine. So the first thing that we do when we're setting up a state machine is we define our finite number of states, right? We talked about any state machine is only going to have a specific number of states and nothing else. It can't have two states. The form can't exist in two states at the same time. It can't have in this particular instance, we're not going to be dealing with any sort of substates or anything like that. We just have some simple states, right? And let's see, this is actually an event, so I'll move that there. But we can say it's not submitted. We can say the form is in the process of submitting. It is has been submitted with success, and it's been submitted, but we have an error, right? And a finite state machine also has a finite number of events that we can send. So we can send a reset event, we can send a submit event, we can send a log error event, or a log success event, right? And then we're going to create our machine, and we'll take a look in a minute at what this is actually doing behind the hood. But the create machine definition is basically going to lay out everything explicitly as it is supposed to happen and behave within our application. So pretty much all of the logic is then hoisted up here to this state machine. So we always have an initial state. Remember, a finite state machine always has one initial state. And in this instance, it's going to be not submitted. It is going to, we're going to have some context data. And remember, I talked about contextual data related to a state. If you're used to thinking of state in terms of just React set state or Redux, you think of state as this like blob, of just whatever data you pass to it, right? Well, that's what context is essentially in this world of thinking about state machines, right? It's contextual data related to your state. And then we actually define our states and what is expected to happen in a particular state when events take place. So when we are in the not submitted state, we expect the submit event to do a very specific thing. It is going to target the submitting state. So once the submit event takes place, we are going to move into the submitting state, and we're going to kick off a number of actions. This action is going to update our context data, and that's it. Basically, all we say is when you submit, go into submitting and update this context data. We're going to update the email with whatever email address comes from the event, and then we go down to submitting. So then we're here in submitting. Now we could also submit a reset event, and that just resets the entire form. So we're going to go back to not submitted. We're going to reset all of our context data, and we're sort of back to square one. We go back to our initial state. And that's it. If you send any other event, remember we've got 4 events here. We've got reset, submit, log, error, log, success. If you send any other event in the not submitted state, nothing's going to happen because we haven't defined any additional events in this state. And this is where this really starts to shine, I think, is because in your app code, you go start sending events and dispatching these events. If you're thinking in Redux terms, dispatching actions. You start sending all these events in your app code, and you might dispatch an event somewhere that you may not have, right? But if you dispatch the wrong event for a specific state that doesn't have an event defined, there's no bug because nothing can happen from that event. So you don't have all of these like weird conditional checks in your app. You just send events to your machine and you let your machine sort out the rest. It's pretty powerful once you start getting into this stuff and realizing what it actually can do for you here in terms of preventing bugs. It's pretty cool. So yeah, we have the same thing in our submitting state. We've got a log error event that's going to get an error message from our action and update that in our context. And it's going to fire off another action that's going to log that in our console for us. You've got a log success action or event rather, that's going to send us to the success state, and it's going to clear our form input, and it's going to update our context with some data. And so on for different states. We've got our error state here, we've got our success state here, and that's pretty much all of our app logic. And then we wrap that up in this use machine hook. We take our machine, we give ourselves a current state value and a send function that basically the send is like a dispatch if you're used to Reducer and Redux speak, but that's what we use to send our messages. So instead of all of that, that dancing through these different states, we send a message to our machine when we start to submit the form, along with an email address from that form, presumably. We throw an error if we need to here, and then we deal with the next event in our catch clause. But once we get some data back, we log success. And again, that's only going to do anything if we're in our submit state, or submitting state, which we go to after the submit message is sent. And then, yeah, we log an error if we need to, and that takes us to our error state. But then once we get down into the rest of our code, we see all we're really doing is checking to see what is our current state value. So we've only got one state value. We're no longer doing this dance between these different pieces of state data. We've got one state value, and we're using that to determine everything else around our app's logic. So if we are to swap that out in our app for our state machine code, we should have a slightly less buggy experience. Cool. So let's just keep trying and see what happens if we get in there. Oh, something went wrong. So great. Now we have all of our content has changed as we had expected. We haven't cleared the email submission form because we didn't need to do that because the submission didn't go through. So maybe the user wants to try again. We're also able to disable our buttons at the same time because everything's based off that one piece of state. So, yeah, it helps us sort of find and eliminate these bugs a little quicker when everything sort of revolves around this one piece of state, which is our current state value. So if we actually take a look at what's happening behind the hood, we're going to do this very quickly because this is there's a lot going on here. But basically, we'll break it down into a few pieces. We've got our create machine function that creates our state machine. It takes in our state machine definition and it actually creates the state machine itself. We've got our interpreter, and we've got our React hook to sort of make everything work with React. So just as we would do with our app code, we start by saying, okay, our state machine has 3 states. It can either be started, it can be running, or it can be stopped. So we're using a state machine in our state machine, or at least concepts within our state machine, which is pretty cool, I think. And then we map out sort of what our definition is going to look like from, with our API. Like I said, we're going to give it an initial state. We're going to give it some context. We're going to define some states, and we're going to define what's supposed to happen within those states when certain events are fired. So if we look at our create machine form, the first thing we're going to do is we are going to define the actual machine object that comes back to us. And that machine is going to consist of an initial state key with a value, its set up actions, and the context data. And then it's going to have a transition function. And that's pretty much it. The rest of the magic happens with our interpreter. So we'll talk a little bit about our interpreter here in a minute. But basically, the idea is the state machine out of the box is just going to give you this transition function. You pass in whatever your current state is and an event, and it determines from that information what should happen next. So we start setting up our context. We have this unchanged state object. So basically we want our transition to always return our state no matter what. But in the event that nothing is actually changed, if we detect that we don't have a matching event, we're going to just return this unchanged state and call it a day. And again, we're going to go through this super quick because I know we don't have a ton of time and this is kind of hairy, but this is a really simple implementation of what you'll see in a lot of state machine libraries. I will share a link to the repo of this so that you can all check this out in depth and review. I wrote a lot of comments throughout to sort of explain the process. We can check conditionals. If certain conditions aren't met within the context, then we can prevent an event from actually doing anything in our state machine, which is kind of cool and really, really useful. And we can define our actions. Remember, we talked about actions or side effects. So if we go back to our app with machine code, we can see that when we hit the submitting state from submit using this action or this particular event, we have this assignment action. That's all set up here in our machine code. This is our assignment action. It's basically just saying, hey, we're going to update some context information, and that's about it. So we're not going to fire off any state transitions from just an assignment action alone. And then we return some new state, and whatever the new state value is, that's the state that we go to based on the definition that we set up. And we could use that directly. You could say, let's create a machine with a given definition here, and you could directly say, what's my initial state, log the value, and you would see maybe idle, and then you would directly call a transition with an action. And if your state definition did something with that action, or with that event rather, you would console log the state value again, and you would see whatever the next state is. But that's not really that useful in practice. We need something to sort of interface with our app code. In our instance, we're using React. So we're going to set up what's called an interpreter. And essentially, I pulled this from the XState docs, but while a state machine and state chart is a pure transition function, is useful for flexibility and purity, in order for it to have any use in a real life application, something needs to keep track of the current state and persist it. It needs to execute our side effects. It needs to handle our delayed transitions and events, and it needs to communicate with external services. So that's what our interpreter function does. It basically gives us a service that we can start and stop within our application to start listening for events and subscribe to all of these updates. So that's what our interpreter function does. Again, I won't go into it in depth here because it's kind of, there's a lot going on, but I will share the code. And then we have our use machine hook that basically takes our state machine and it sticks it in our React local state, and it lets React sort of access it the way that we are used to interfacing with things in React, which is kind of cool. And that's what gives us the ability to create this state machine here and use it within our code. Now, the really cool thing about this whole idea of state machines is that you don't actually have to write any state machine code to use the concepts. So we've gone through all of this. You can see we've got our big state chart here, but the concepts, the core concepts that are truly most important are this idea of a finite number of states for more granular control over our state logic. You can really achieve that with just some core tools that React gives you out of the box. We've got this concept of a reducer. And if you're familiar with reducers, basically that's a tool that we sort of got this concept from Redux, but it's now baked into React Core. And we can use a reducer function to help us deal with really complex nested state nodes in sort of a more centralized manner for a lot of these same benefits that we get with state machines. With a small adjustment to how we think about reducers, you can use a lot of these same ideas with just reducer functions, right? So when you define a reducer, we're used to accepting a state and an action. In this instance, I just named my action an event because we're thinking of these terms a little bit differently, but we're sending events. We're not dispatching actions, we're sending events. So I'm going to call it an event. It's the same concept, but I'm going to call it an event. And based on our event type can be any of these number of events that we created up here at the top here. Based on our event type, we can then create a second switch statement to say, what is our state value currently? And this is going to give us a lot of the same benefits as our state machine did, where we are limiting the ability of the action to do anything to what the current state is. So if we don't explicitly tell it to do something when a given state is provided, it can't do anything. It will dispatch an event and nothing will happen because all we're doing is returning the existing state if this criteria is not met. So you really get a lot of the same benefits of using this idea of a finite state machine. You can get a lot of those benefits by just using reducers if we can sort of remodel how our brain thinks about the reducer and how we can sort of make it do a little bit more for us. So we can switch based on the event type and switch based on the state value, and then start doing things with our context data accordingly. And we can assign a new value, we can update our context data, and then so on and so forth throughout a reducer. And going down into our app code, it's going to look very similar, right? You get the current value of the state with the value attached along with the data context, and you have a send function. It's really dispatch, but we're going to call it send because we can name things whatever we want, and that's the beauty of it. And what's really cool is this API in this machine code that I showed you is identical to the API of the most popular state machine library, as far as I can tell, which is XState, which was written and maintained by David Khorshid. It's a great, tremendous library. It's what we're likely going to use in Reach UI. I highly recommend checking out the XState docs. There's a lot of really great stuff in there, and highly recommend following along with David on Twitter. And yeah, that's we'll just wrap this up. We can go back to our slides if that's possible. I don't have much more, but yeah, I did want to thank everyone for coming out and leave you with a few references. Like I said, check out the XState docs, full of really great stuff there.
Is this what we're looking for? Some links?
Yep, that's the one.
All right.
Check out Reach UI, ui.reach.tech. That's going to send you to all of the fun tools that I'm working on over at React Training. Check out reacttraining.com. And as a bonus, I'll share with you all, just because I don't think links on a screen are really the most useful. I'm sure you can distribute links amongst the participants here, but there's a couple other things that I'll share along with the repo of the code that I just showed everyone. And if anyone has any questions, feel free to reach out to me directly on Twitter. And that's all I have. So thank you very much.
Thank you so much, Chance.
Let's give it up for Chance.
You got a few minutes for some questions, Chance?
Let's do it.
All right. Anybody have some questions? Yep. You grab him.
All right, here we go.
We're going to be running around.
Hey, are there any instances where we shouldn't use state machines in UI?
I wouldn't say that there's a hard and fast rule. So let's take XState, for example. XState is just a library. You don't have to use XState to create a state machine. Like I just showed you, you can represent the same sort of logic with just a plain reducer. So if you're already working with React and you have sort of a very small interactive piece, and it's only, let's say it's only got 2 states, and there are only like 3 events that toggle those states, right? Bringing in a library like XState is probably overkill. So that might not necessarily be something I would recommend for that particular use case. Depending on where it fit in with the overall application, maybe you could reassess that. Maybe XState's not that big of a deal. But if you're working on something smaller and complex, like a component library, so for us, we are using state machines, but we're not like pulling in all of XState because we're dealing with these small components, and we don't want to make people pull in a big dependency for a small component. So we're sort of condensing what we need from XState and using one of their smaller modules to get the job done. However, I would say the concepts of state machines are completely usable everywhere in UI. If anything that's stateful, essentially. If you don't have state, then of course you don't necessarily need a state machine. But if you have stateful logic, I think just starting with the idea that there are going to be a finite number of states is a really great place to start. And from there, it's like any other tool: scale and use what you need, and assess it as you go.
Well, thank you. Who else? Who had their hand raised? Yep.
Thanks. Yeah, could you tell us a bit about best practices for testing? Do you test every transition? How do you inject? How do you do some kind of dependency injection for those purposes with the hook pattern that you used? I think those are the 2 main ones.
I honestly don't test my state machine transitions. I test them in real life. When I write tests personally, and don't take anything I say about testing as a best practice, because it's probably not, but I think you should test your application code the way that users use your application code. Your users use application code by clicking on a button, and they expect something to happen once that button is clicked. And that's what you test, right? So that's what I test. So when I'm writing tests for Reach UI, I'll pull something in like React testing library and render something in the testing environment and simulate clicks. I don't care personally if a certain state machine event is firing. I care that the thing that is supposed to happen happens. So that's just my personal approach to testing. I don't really do too much testing of implementation details. I also, if I'm relying on that's not to say that if you're building your own state machine function that you shouldn't test that function and sort of isolate that function and figure out how to test it. I just don't really do that because I use a lot of the stuff provided by XState, and they have tests already written for that. So sorry if that's probably not the best answer, but I would say best practices are test your UI components the way a user would use them. And if you want to test your own state machine function, I would take a look and just see how some of the libraries are doing it, because I'm not really sure.
Cool. Do we have any more questions?
We got one over here.
Damn it.
So what sort of flows do you model with state machines?
I can probably, you know what? I can't do it on this because it's not gonna let me, but I was gonna show you a little bit, but basically Reach UI is a component library. We've got a menu button, we've got a list box, we've got check boxes. Like we build small components. So think of all of the interactions that a user can take with a list box, for example. A list box, if you're not familiar, it's basically a custom select menu, right? So user clicks on a closed selects menu. It's in a closed collapsed state. They click on the select box in its closed state, and we fire off a transition to the open state. And based on what is in the context data, it's going to have a certain item in that list box selected, right? So all of that logic goes into our state machine. And when we're actually building the list box component, we're not in our keyboard handlers, in our click handlers, we're not going in and saying, send this particular active item into our use state function. We're just sending an event. We're saying in our event we might include some contextual data that we need, but our state machine takes care of the rest. It takes, if our list box is clicked in its closed state, it's going to go into the open state. If it's clicked in its open state, it's going to go back to its closed state, and with certain other pieces of contextual data provided by the event. So yeah, that's the kind of stuff that I work on, but it's really useful for a lot more complex applications as well. I think actually, if you look at the source code for Gatsby, they use state machines quite extensively under the hood in spinning up the environment for Gatsby. So if you want to look at like how state machines might work in some other systems, and from the front end to the back end to anywhere in between, there's a lot of great tools out there that utilize state machines in their own way.
Awesome. Any other questions? Nope. Awesome. Well, Chance, thank you so much for coming on. Sorry for all the frustrations. Glad we got the slides up. You said you'll be sharing some links with us, and definitely the repo that you were working on.
Absolutely.
Awesome. Cool. Yeah. You're more than welcome to join into the Discord. I can share it out in the Discord for all those that are in there, and I'll probably post it on the meetup as well.
Sounds good. Thank you all for having me. Thanks.
Thank you so much for coming, man.
Let's give it up for Chance.